Hmm.
Okay. Which is the next one? Next one.
Or just do D. It would be. You can do it verbally, right?
Yes. I got my calculator. Arc cos 0 would be 90, and cos 90 would be
0.
0.
Hmm. Okay. The next thing, question number 4. Just do E and F.
And tan, tan, arc cos, give it tan inverse of cos minus root 2
Which one are you doing?
by 2.
This
4.
is
Oh, that I'm doing 4 C.
already do 4C.
It looked like E.
Hmm.
Minus 1. Which one next?
-1. This is for 4C. Hmm. Okay,
Which
okay,
one did you
okay,
say?
okay. Yeah, for E and F.
4 E and F. It actually, I'm not joking. Minus 90. So cosec is 1 by 90. 1 by sine. I mean. 1 by sine is equal to 90. So sine is 1 by 90.
What are you doing?
Yes.
Hmm. So first of all, you have to do sine inverse of -1. What do you get? -pi/2.
Yeah.
-pi/2.
90.
Then you have to do 1 over sine of -pi/2.
That's what I did. Sir, can we unzoom? It's so big.
Okay.
Oh, wait, no, it's my sensitivity. Yes, it's better. Okay. Is that what I'm supposed to do?
No, not sine 1 over 90. It would be 1 over sine 90.
1 over.
And sine -90, in fact, because arc sine was -1.
What?
So see, you had the question was,
It's minus 90.
hmm,
But am I doing it right?
this step is not right. This last one.
Okay, how do I fix it?
1 over sine -90. 1 over sine -90.
1 over sine. What is it?
Check in the calculator.
Minus 1?
Put this in the calculator and
The
put.
answer minus 1.
That is
Oh, I did it already before. I thought how.
nice.
But
Uh,
how can it be minus 1?
how can what be -1?
R2 arc sine 2. Okay, I can do 2 sine inverse right here.
Let me see.
Sir, sine
Hmm.
sine inverse is not equal to 1 by sine,
No.
right?
No, 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 no.
No, but
1
how?
1 by sine is cosec.
Yeah, but how is it not equal to sine inverse?
So see, we have got this expression, sine theta is equal to 1 by x. Alright. if sine theta is equal to 1 by x, then I can say uh, theta is equal to theta is equal to sine inverse of 1 by x. That's one thing we can say. The other thing I can say is uh, hmm, x is equal to 1 by sine theta, or x is equal to cosec theta. So this 1 over sine is different from sine. This is called a reciprocal of sine, 1 over sine, cosec. These are called reciprocal functions. And this is called inverse of sine. We do
See, I already know that,
hmm, this is different. See, this when I'm doing sine of a function, when I do sine inverse, I find out the value of theta. When I do 1 over sine, it has got a graph of its own, which is on top of sine graph.
so when I did these type of questions, right, I always thought that I'm doing 1 by sine. That's why I thought it was
the,
just.
this is 1 by sine. For example, if you make this thing like this, then it would be 1 by sine. But if you turn this into this, then this is not 1 by sine. The left hand side thing is not 1 by sine, the right hand side thing is. So remember, sine inverse is done to find the angle, whereas 1 by sine is a function of its own, it's reciprocal of sine.
So
Okay.
now what?
Question number 5. This is verbal, like
Verbal?
hmm,
Which one?
5.
5. Given that the arc sine is equal to theta, where write down the first two positive values of x, satisfying the equation sine x is equal to k. Given that arc sine k is equal to. Is that alpha? What is that?
Alpha.
Okay. Given that arc sine k, can you zoom in? Very bit zoom. Yes, that's better. Given that arc sine k is equal to k, write down first two positive values of x, satisfying the equation sine x is equal to k. So, 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 I still don't know what to do.
Hmm. This is a bit confusing. Let's see on the board. So I have got uh, this as the graph of sine. I'm drawing only the first half because it asks me for two values and it has to be between 0 and 1. So this is 0 and this is 1 over here. So two values which will give me sine x is equal to k. Okay, so what two values would give me sine x is equal to k? uh, these are these are hmm, if I have to find, for example, this particular value of I made a mistake, just a small one. This is what I'm looking for. This. Okay, so these are values of theta on x-axis, right? This theta is found out by sine inverse of what is it in same question? Sine inverse of k. Okay, so sine inverse of k will give me one value for which sine x is equal to k. if sine inverse of k is equal to x, then k is equal to sine x, right?
Yeah.
Okay, so I have to find out for this what two values will give me k is equal to sine x. So to find k is equal to sine x, the first value can be found out by doing sine inverse of k. That will give me the first value of x, and the other value of x will be pi minus sine inverse of k. Okay, so we have to find this value and this value. If this value I can find out by doing, this is k over here on y-axis. So sine x is equal to k, right? If sine x is equal to k, then to find out this value I have to do sine inverse of k.
Sine inverse of k.
For example, this was 0.5. Then to find out value of theta, what would I do? Sine inverse of 0.5, right?
Yeah.
That will give me a value of theta, let's say 30 degrees. Okay, and the other value would be so this first value I got by doing what? Sine inverse of k, which was 0.5 over here.
Right.
And the other value is, so 30 degree is equal to sine inverse of k. The other value is pi minus 30. So sine inverse k, pi minus sine inverse of k. The other value is this one. Did you get it? I'll repeat it, no problem. No problem. I'll try to explain it again.
It's going all over my head. Why?
Because it's just that they have started using arc and putting things in a confusing way. I don't know why, but their choice. Okay, so let's assume I have to give as a general function, if I have to find value of theta, I take sine inverse of y, whatever the value of, for example, I know sine theta is equal to 0.5. This is same as writing sine x is equal to k, or I'll do this parallel to this one. So I write over here different ink, sine x is equal to k. Alright, okay, now to find value of theta, what do I have to do? Theta is equal to sine inverse 0.5, or in terms of x and k I can say x is equal to arc sine k.
To find the angle x.
I'm doing this thing in both in terms of x and y and in terms of theta.
So it's different for x and y.
It's the same. I'm just trying to give you a general rule.
Okay.
If instead of saying theta, and if instead of saying an actual, if 0.5 or some other value, how could I say a general equation which would give me value of x, or which would give me value of theta? I'm trying to find a general equation which would give me value of theta. So I can do that by saying x is equal to arc sine k. If original equation is sine x is equal to k, then I can say x is equal to arc sine k. Okay, so this is the first value of theta, or the first value of x, right? This would give me 30 degree. So this is the first value of theta. The other value of theta would be pi minus x.
Pi minus x. Okay.
Okay, so then I say subtracting both sides from pi. So on left hand side it will become pi minus theta is equal to pi minus sine inverse 0.5, right?
Uh-huh.
So on the right hand side it will become, I mean the in the equation in the form of x and arcsine, pi minus x, this is the value that I'm trying to find out, is equal to pi minus arc sine k.
Okay.
Okay, so these are the two values which it is asking me to calculate, arc sine k and pi minus arc sine k.
Okay. Why are you subtracting the pi again?
From pi, because I know for sine that it repeats itself at pi minus x or pi minus theta.
Just confirm. Okay. Next question.
Yes, please.
Um,
There is nothing new in this exercise. All that they're trying to do is to make you used to this concept of using arc sine instead of sine inverse. Otherwise, functionally, this exercise is everything that we have learned before. Nothing new in it.
Given that x satisfies arc sine x equals to k, okay, what does that mean? X satisfies arc sine x?
Just see arc sine x is equal to k. Because for all values of sine inverse of x is equal to k, we cannot find out sine inverse. So x satisfies arc sine x is equal to k, where k is 0 and pi by 2. Pi is 90 degree, right?
Right.
So it means that I'm looking for a value of x which will give me sine theta is equal to between 0 and pi by 2. So sine 0 to sine 90 degree.
Okay.
So sine 0 is 0 and sine 90 is 1.
Right.
So x is a value, sorry, k is a value between 0 and 90 degree, and x is a value between 0 and 1. When k is between 0 and pi by 2, 0 and 90 degree, what are the possible answers that I can get for sine? The minimum value would be for sine 0, which would be 0, and the
Right.
maximum value would be for sine 90 degree, which is 1.
Right. Right.
Alright, so this means that this x has a value between 0 and 1 degree. X satisfies this equation.
Okay. There's a possible range of. Okay, isn't that what you just said?
It's between 0 and 1.
Yeah. Okay. Express in terms of x cos k. Mine is okay. Can you give me a hint?
Sine k is equal to x. Okay. Um, if we take square of both sides,
Okay. Then is it?
wouldn't it be 1 minus cos squared k?
That's what I meant to write.
I mean, just 1 second, just 1 second, just 1 second. Uh, Sine squared k is equal to 1 minus cos squared k. and you have to then give value of.
I was right pause because I wrote that wrong. I wrote the next step wrong. Right?
Wouldn't it be 1 minus x squared, because
Yeah, x squared is 1 only.
no, no,
What do you mean? Oh, damn. Yes. I'm
plus.
sorry. My mind very slow.
Okay. Next one.
Okay. 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 What? What? Okay. Okay. So over here, what I'm gonna do right now,
And
at this
I'm sorry,
point in time,
just a thing. Since we are going for between, the minus one will be ignored over here in the solution, because of we have to do between 0 and pi by 2, so
of
it would
course,
only be the positive one.
I knew that all along.
Hmm.
X, tan x, x cos is that it? And so then tan,
Just write the value of cos k.
and then from the yeah previous.
Under root 1 minus x squared. Alrighty.
Sir, the Mocha song is not getting out of my head. What can I do?
Mocha. Who do you think would win? Who do you think? Um, if it were between 0 and minus pi by 2.
0 and minus pi by 2.
Hmm. Just 1 second, there's somebody at the door. Let me go check it. I'll be back. Alright, I've got a question. I,
Nice.
the question is, What's the superpower of a milkman?
Delivering you milk.
Next question.
Yes.
Why do all superheroes, or most of them, wear their underwear on top of their trousers?
Did your milkman do that?
Not Superman, Batman, all. I don't know about
And
Flash.
milkman. Did your milkman actually? I've never seen a milkman do that.
I mean, my milkman doesn't do that.
Okay. I was like, you have a milkman. First time I was like, you have a milkman. Oh my god. And then I was like, your milkman's doing that.
uh
Okay.
I mean, he's uh, in some way you could call him a superhero, but not that superhero. Um, that's why I first asked you what are his superpowers, and then the next question: why do Superman and Batman they do that?
They're
Okay.
a genius.
If this domain were instead minus pi by 2 to 0.
Okay, so then we would, how would, okay, so then we would, for cos k, the answer would be the minus thing
Hmm.
instead of plus, and
For sine,
for
the sign
for
would be,
yeah,
so the
for
whole
cos it
answer would
would be
become
minus,
minus.
and for tan it would also be the minus instead of the plus
Excellent,
symbol.
excellent. Um,
Seven,
no, there
seven.
won't be any change in 10k.
There
Both,
will,
I mean, right now both sine and cos are positive, right?
yeah.
So in that particular range, minus pi by 2 to 0, it would be the fourth quadrant, right? So both will be negative, or one will be negative.
Yeah, so
Cast.
there's only negative. We take into consideration the positive answer also?
Mm,
No, right? It's just the negative. The positive answer will be more than uh, 0.
minus pi by 2, 0, it would be in the fourth quadrant, right?
Minus pi by 2.
So this is
Yeah.
0 to pi by 2 to pi to minus pi by 2 to 0. So this is what we are talking about.
Cast. Okay.
Hmm. The answer would stay positive.
Uh-huh. Uh-huh.
Hmm. Because also if we look at the diagram, if we look at the diagram, um, this is this would be for sine, and for cos it would be like this.
Uh-huh. Right. It would. It would.
Hmm. Hmm, 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 hmm.
It would be
So
like
we're
this.
talking about this particular portion, right? And in this particular portion, it would be negative. Hmm. The 10 would be negative. That's what you said?
Yeah.
Hmm.
Tan would be negative because here it will just be negative.
10 would be negative, cos would be positive. He's
Y-
asking for both answers of part B.
Yeah, so look here, look here. Here it would still be negative. Here the answer would be minus root 1, whatever I just wrote. And over here, instead of it being x divided by uh minus x divided by plus, it would become minus instead.
Hmm. Hmm. So
That's what I
yes,
meant.
yes, 10 would be negative and cos would be positive. Sorry, yes, because you're doing this value of x, 10k is equal to x by 1 plus root 1 plus x squared. This x would become negative.
Yeah, that's what I'm saying.
Hmm. Hmm, correct, correct. We're both saying the same thing in different words. So yes, on to next question. Sketch the graphs.
Okay.
Um, Sine inverse of minus x into minus 2. Have you done graphs of arc sine? Are you there?
Oh yeah, I was muted. Uh, no.
Mm,
Maybe I don't know. I don't
hmm,
remember.
hmm. So we have to do for what values? We have to do for uh, have they given the domain? They haven't. So first of all, let's do graph of 2 arc sine x. 2 arc sine x. For sine inverse of x, let me show you.
Uh,
Not ABC, functions. And in functions, we are talking about sine inverse of x. This is what sine inverse of x looks like.
uh-huh.
Alright, it becomes asymptote at, not asymptote, it just goes to, this is what it looks like.
Uh-huh. Uh-huh.
Okay, and then if I'm doing 2 sine x,
Uh-huh.
2 arc sine x, so arc sine, hmm, 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 2 would mean it stretches vertically by 2
Where? In the bracket or outside the bracket?
outside the bracket.
Then it would be up by 2.
Isn't
Like,
isn't that by plus and minus? I mean, you mean stretched vertically by
uh,
2.
stress, yeah.
Okay. So the same values they'd get at twice. So for example, uh, this, let me first change it to radians. Is it in radians or is it in degrees?
What? Okay.
Hmm. Radians was fine.
Irradiance, irradiance. Uh,
So minus 1 and positive 1, but vertically stretched, and pi by 2 plus pi by 2 would make it go upwards by pi by 2, right?
price outside the bracket, yeah.
Hmm. Okay. So if I do those conversions over here, so 2 sine inverse x will be like this.
Uh-huh.
And how do I write pi by 2? Does it give me pi
Why was it
by
showing my
2
first question? Why is
plus
sine inverse of x showing 1.5
sine inverse of x is showing 1.5?
upwards?
One second. This is what you're talking about?
Yeah.
Mm, I don't think I get your question again.
You see to the left which says 1.5.
Sine inverse of 1, what do you get?
1.5, like
Sine
on
inverse
the
of,
x-axis it's 1 and on y-axis it's 1.5. Why is it 1.5?
that's what I'm saying. What's sine inverse of 1? 90
Oh,
degrees.
okay.
90 degrees is what? Pi by 2 radians.
Mhm.
What's the value of pi by 2?
Pi by 2 is, I don't know, 90.
By 2. 1.5707.
Okay. Okay. Okay.
That is why. And over here, since minus pi, it would go to minus 90, it will become minus 1.5707.
Mm-hmm.
Okay.
Indeed.
And then when I make it 2 of this, so 2 of sine inverse of x will become what? 2. It will go maximum to 1.57 times 2.
Uh-huh.
1.57 times 2, which is 3.14,
Right.
both in the negative and the positive quadrant. And then pi by 2 plus, it will move upwards by pi by 2.
Right.
This is the first one. Then tan inverse x, tan inverse x, tan inverse x. Do you have the book open?
No.
If you could please open it. Otherwise, let
I
me.
opened it.
Okay, thank you. We are on page 75 of PDF.
Okay.
2 times tan inverse. The next one that I want to do is tan inverse of x. So functions tan inverse of x. This is what it looks like.
Uh-huh.
It becomes asymptote at what?
Where is tan? Okay.
It. What's the maximum value?
Tan
Tan.
inverse of x.
Hmm,
Why? I'm so confused. How
why?
do you draw arc? How do you draw inverse like without this?
So you take values for 0, 1 and minus 1. For tan inverse 0, for tan
Okay.
inverse 1 and tan inverse minus 1.
Okay, on your calculator,
Hmm.
and then you just plot it on the graph.
So we know we have to know a few things. For example, for cos and sine, it would be limited to the maximum values of cos and sine. So for sine, it will be pi by 2, and for cos, it will be uh, what? Also pi by 2, 0 and pi by 2, and minus pi by 2. The values, because they reach the maximum and minimum at these values, 0 and pi by 2. In the positive and negative, they are between 0 and minus pi by 2. So that would be the limit of these values on y-axis. One thing I don't know if you have noticed or not, previously when we used to draw graph of sine x, we used to have these angles over here on the x-axis. Now we are doing sine inverse of x, so the graph is sort of turned rightwards clockwise 90 degrees. So you have got angles on y-axis and you've got the resultant values on x-axis.
Ah, yes.
So right now this y-axis, it is giving me angles. Okay, and these are the values of the function. So uh, for sine and
What
cos,
is the
let me.
first asymptote? What is the first asymptote?
Asymptote is this one, this particular line. How much is it? Minus 1.5, I think. Minus 1.5.
Okay.
1.5 and minus 1.5. So check tan inverse 1.5. Tan inverse 1.5.
I'll have to put this in a calculator and then find it out and then sketch it out.
Hmm. Tan inverse of 2. No, 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 no. So
Tan inverse 1.5 is
asymptote would be pi by 2. Asymptote would be pi by 2 because 90 degree, at 90 degree it becomes asymptote, right?
What is pi by 2?
1.57.
1.5. Yes.
So asymptote would be at 1.57.
Okay. So the next thing will be at from 1.57, like above it,
Above it at
diagonally.
1.57 it will become parallel to x-axis, and below it at 1.57 it will become parallel to x-axis.
Okay, now if you were to draw another line above this line, I mean another tan inverse of x above this,
Hmm.
it would uh, not touch 1.5 but come from downwards, right? And then reach till 3 or something, 3.1, whatever.
I don't get what you're saying. If you were to draw another 1.5, another tan above it,
Yes, tan
uh,
inverse. Draw tans. You know how side by side you draw tans, right?
hmm.
That way I'm telling
Oh,
the
oh,
other
oh,
way
oh,
around.
oh, 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 oh. Hmm. For tans, I don't think that would be the case, because see, up and down, we haven't got more tans for tan inverses. Tans we have got multiple,
Uh-huh.
but tan inverse we have got just one.
Okay. Whatever. 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 Okay, so for
because
all of these,
because
I'll just
for
have to put
x,
values in the
see see see
calculator.
see see the value of tan inverse, it goes from 0 to 1.57 and 0 to minus 1.57. The values of angles, they keep on increasing, so you complete one round of 0 to 360 degree, then you can do another of 360 to 270, then you can do another of 720 onwards, but you cannot do that for tan inverse, which you are putting on x-axis.
Right,
So that
right,
is why you'll have just one for tan inverse. Did you get this point?
right, right,
No?
right. I didn't. I
Okay.
didn't.
So the next question that we have, the second one, it says pi minus sine inverse of x. So pi minus this thing would just make it go down?
I minus tan it. Which one? Oh yeah, okay.
No, up.
Where? Where? Which question?
Part B.
It's tan.
Part
You
B,
said okay.
7B.
You said
7B.
sine. Yeah, you said pi
Sorry.
minus sine. That's right.
All right.
Yeah.
All right. Y is equal to pi minus arc tan x. One thing. So first of all, doing minus arc tan would make it turn this way.
Yeah. Yeah.
Let me write all of these. Control C, enter, Control V, and this one is minus. So this is minus, and then to this minus I add pi.
Uh huh. Uh huh.
So
Uh
pi
huh.
plus or pi minus tan inverse of x. This is what it would look like.
Uh
It would
huh.
shift upwards,
Okay.
because to minus tan x I am adding pi. Okay. Uh, this. Then the next thing that we have is, the next question is what?
A good
Uh,
one.
cos 2x plus 1. 2x plus 1. So cos of 2x would, sorry, cos inverse of 2x. Let's first do cos inverse of 2x.
Okay.
So
How would I write it? How would I do it without Desmos?
without Desmos, a good way is to find values of 0, 1,
So
and
cos
90
inverse
degree.
of one. So cos inverse of wait, let me do it. So cos inverse of one,
For,
which is 0, right? And so and then the other one will be cos inverse of 3, which is not there. Now what?
hmm, if we take x is equal to 0,
Then the answer will be 0 because cos inverse of 1 is 0.
at 0 I've got 0 for this one. Okay,
Yeah,
then at 1 what do I get?
you get cos inverse of 3, which doesn't have a value.
Hmm. So I don't take 1, then I take, so it's between 1, it's less than 1. Let's take 1 by 3.
Mm.
Cos inverse of 2 by 3 plus 1 would give me what?
Oh.
So if I want x to be 1, what value do I have to take? So 2x plus 1 is equal to 1. So x is
Uh-huh.
equal to 1 by 2.
2x plus 1 is equal to 1.
Hmm.
Okay. What did you say again?
2x plus 1 is equal to 1. What would it give me as x? 0.
Yes.
Hmm. So cos inverse of 0 is 1.
There has to be another way.
This is the way. This is the way I'm telling you.
No.
See, we have to take the maximum value and the minimum
I
value.
feel
The
like you have to draw some line and then reflect it or something, something.
mm,
Can you draw cos 2x plus 1?
cos inverse 2x plus 1, you mean?
No, just cos.
Okay. Cos 2x plus 1.
Okay. So now I will draw a line. Okay. Okay, now can you put in another this thing cos inverse 2x plus 1?
Hmm.
Actually,
Hmm.
just do cos 2x and cos inverse 2x so that it's easier for me to see. Okay. What do they have in common? What do they have in common? What do they have in common?
Let's do simply for cos x and cos inverse of x.
Okay, but doesn't seem to have anything to do with each other.
On y-axis, since we have taken the y-axis values, they might have been better if they had been in pi, in form of pi. So over here you have got what?
Pi
Hmm.
by 2.
It's 1 when cos inverse of 0.
Ah,
No, it's 1 at what? 90 degree? 90 degree is pi by 2. Again at 1.57 it will be 0.
it's what? Pi by 2.
So
Huh.
pi by 2 over here, the highest point will be,
So yeah, it's just a reflection, not reflection.
its rotation.
Rotation. Yeah. Okay, okay, okay. But how would I draw it? How would I draw a rotation? So here we can see that 1.5 is a thing. So 2x plus 1. 2x plus 1 cos is going to be uh 2x. Okay, it will be 2 upwards. Sir, can you put 2x plus 1? So it will be,
Cos x of 2x plus 1.
yeah.
Cos of 2x plus 1.
Yeah, so this 2x cos inverse of 2x plus 1 would be um touching the y axis, I mean touching the x axis at 1, not touching above the x axis at 1.
Could you draw a rough drawing on the concept board?
I guess so. So this would be here. No, I was wrong. Okay.
So one thing is that this cos inverse of x, it would have its values between uh, 1 and -1. Is that easy?
No.
Cos inverse of x, it will have its values on the positive side on the x-axis 1, on the negative of x-axis -1.
Right.
Okay. The other thing is its highest point will be 1.7, 1.57. I mean, that's the only point it will have.
Okay.
This, it will intersect the x-axis at pi by 2.
Okay.
Okay. And what else? What else? It will be a curve, and then you do 2x. When you do cos inverse of 2x, it will shrink to half. So this will be 0.5, and this will be 0.5 comma whatever
Uh-huh.
pi, because the maximum highest it goes is to pi, and this will stay as it is, pi by 2. And then when you do cos 2x, did you get the till cos 2x, cos inverse of 2x?
Yeah.
Okay, and then when you do cos inverse 2x plus 1, it will shift to the left.
Yes. Okay. But 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 so cos 2x plus 1. So cos 2, I'll just have to do cos x first, okay? And then I'll switch the domain and range, right? And I'll get an answer.
Hmm.
And from there, from there, I have to take into consideration what's in the bracket and what's outside the bracket.
Hmm.
Okay.
A rough rule is to simply see that this is what the graph of, I'm saying grass, cos inverse of x is like this. Okay, and sine inverse of x is this.
Uh-huh.
And tan inverse of x is this.
So easy.
Since we
Well,
have used these graphs of sine, cos, and tan so much, at least sine and cos so much, that we can just draw it from
yeah,
memory. Okay,
yeah,
so that is what we'll have to do with sine x and cos x as well.
yeah, yeah,
It's only
yeah,
that the x's they have switched. We used to have one values over here and the other value over there, so that switched. That is why it's a bit confusing. Draw it
yeah,
a few times, draw it a few times, and you'll see it will be easy for you then.
yeah, yeah, yeah,
Okay,
yeah.
let's inverse of minus x. If I've got sine inverse of x and I want to do sine inverse of minus x, what would be the change in it?
Sine inverse of x and sine inverse of minus x. So sine inverse of minus x would be rotated like left side to the right side and right side to the left side. So inverse, yeah.
Okay, then it says 2 of, let's first do 2 of sine inverse of minus
So
x. So
minus 2, so they will just multiply by 2 um, in the y direction. Yeah.
and minus 2 will be,
It won't be minus. Yeah. There. Ah, that also. Okay. That's good confusing question.
Ooh, nice.
Okay.
Okay, sir, I'll do these two questions later. We're supposed to have 45 minutes. I mean, we're supposed to have 1.5 hour class, right?
Hmm.
Let's just do the half hour tomorrow, please.
Because you.
No, no reason.
Hmm, no
Just
reason.
simply
Nothing special.
nothing special. Just normal day.